Alright, I just did this one and I forgot to record, so this one should go a little bit more smoothly. Let's try to draw this again. Oh boy. I don't know how I'm gonna figure this out. Let's try to do it like this. Oh no, that's nice. Nope. Good enough. Whatever. Alright, so a block here of mass M. They don't give us the mass, so it's going to complicate everything a lot more. We have our scratchy part right here, which we know has a coefficient of friction of 0.4. The mass they didn't give us, point A. We know the velocity is equal to 8 meters per second squared. We know that point B is after some length L. Oh, we know this is at a angle theta equals 30 degrees. We know the length of the scratchy part is 0.75 meters, and we know that the scratchy part starts at 2, right? So it's 2 meters. Okay, so let's figure out where the height of point B while we're sitting here, not doing anything. You know. So the height of B is going to be the Pythagorean theorem. This would be theta. So if this is 0.75, theta is 30. Sine of 30 is 1/2, so 0.75 times 1/2 gives us an extra height of 0.375. Not that bad. So that means the height of B is this 2 plus that 0.375 that it goes up. So 2.375 meters. Okay. So here's a general game plan. Let's try changing color, because I haven't done that yet. Ooh, mystical. The energy at B is going to be equal to the energy that it had at A, but minus all the energy that it lost due to friction. So how we would write that is the kinetic energy at B, assuming it's still moving, going to be 1/2 mvb squared, plus the potential, which is mgh, the height of B, and that's going to be equal to the kinetic energy at A, 1/2 mva squared, minus all of that friction, the work done by friction, which is the force of friction times the distance. Okay? Or that's L, right? So we're going to plug in L for the distance here. Right, so we got to figure out what that force of friction is. And let's look at that area right there. So what it would look like is just this mass M on a ramp. Okay. Right, so the force of friction is going to be equal to the normal force times the coefficient of friction. And we know from every other thing that the normal force, if we looked at this at a free body diagram, we'd have the friction, mu, Fn going to the right. The component of gravity would be mg cosine theta. The normal force would be also mg cosine theta. I think we've covered that a bunch of times, and if you don't get that, then we'll go over that later. So the coefficient of friction is going to be mu g, or the force of friction is going to be mu g cosine theta. Okay, so that's going to plug in right here. That's the force of friction times distance. So let's plug that in variable-wise. and see if we can cancel out these m's, because we don't have m, and that's what makes this more complicated. So 1/2, I'm going to scroll down a little bit to make this more comfortable. 1/2 m vb squared plus mghb is equal to 1/2 mva squared minus the force of friction, which is mu mg cosine theta times the distance. And from now on, I'm just going to put the distance out in front to stop putting it at the end. Okay, and we see that the m's do thankfully cancel out. So we're left with 1/2 the b squared plus GHB equals 1/2 VA squared minus mu G cosine theta, and D minus D mu G cosine theta. So we are looking for the velocity at B, right there. Okay, so what are we going to be left with? We're going to have, we'll subtract that. So we have, check my algebra, but VB should be equal to the square root of 1/2 VA squared minus D mu G cosine theta minus GHB all times 2. Alright, so if we scroll this down a little bit, we are going to have, just solving for that, 64 times 1/2 is 32. Ooh, weird. 32. Cosine of 30 is that 0.866. 30 cosine times 9.8 times mu times the distance. Okay. Right. Is 2.546. Minus GHB. So the height at B was 2.375 times 9.8 is 23.275. Okay. 23.275. Okay, that's all times 2, and then take the square root of that. Okay, so 32 minus 2.546 minus 23.275 equals 6.179 times 2 equals 12, and take the square root of that, and we get the velocity at B should be equal to 3.515. I guess, I don't know.